Let's try. Okay, so I'm going to go work on the equations. If you have any questions, you let me know. Okay, so this is it, Tuesday. And this is going to be, and also I posted the assignment going to be due, okay, for next week. This is one section from chapter 5, 5.4, and then these 3 sections on chapter 6 that we covered, or we are going to finish it tonight. Okay, so this is all the assignments that you're going to have. Let's see if we can make it better. Yes, it seems to be better. Okay, now, so I'm going to review again the equations that we talked about it. Okay, so we want to example. There are 3 groups, if you like, and I give you example from for all of them again. We want to find, okay, this is it, find the solutions of each equation. Equations in the interval, if you like, okay, when the variable is going to be between 0 and, I go with the x, your book go with theta, it doesn't matter. Okay, we're mostly interested in the particular solutions. Okay, we find the solution of each okay, of each equation, but in this interval. Okay, so we start with the equation that we can have. So we can have a sine equation, if you like. So this is it. You may be given 1 minus radical 2 sine x equal to the 0, x or theta. First thing to do, you have to isolate the sign. It's like when you solve for x, okay? So you isolate the sign. So this is going to be negative radical 2 sine x equal to the negative 1. Okay, so you divide by radical 2 or negative radical 2. So that gives you sine x equal to the negative 1 over negative radical 2, which is equal to the 1 over radical 2. Okay, 1 over radical 2, you rationalize it. You know that you multiply by radical 2 over radical 2. So the result would be a radical 2 over 2. So we get the sine x equal to a radical 2 over 2. Okay, you see, when you're solving this equation, we are interested in exact solutions, unless we are going to tell you that use your calculator to solve this equation. If they say use your calculator to solve this equation, means at the end you can use your calculator and give us some decimal numbers. But if we won't say anything, you have to find the exact solution for us, okay? Now what you're going to do, you go to the table to find an angle whose sine is radical 2 over 2. We talk about the general solution that we're going to have, you are familiar with, but since they ask for the 0 and 2 pi, so you can use the 0, okay, you can use the table and you find it. Sine is positive. You see, you know that this is going to be the case. Okay, this is going to be the cosine and this is the sine. Since the sine is positive, your 2 solutions are going to be, one of them is here and the other one is going to be here, okay? So an angle whose sine is radical 2 over 2, you know that that angle is going to be pi 4, 45 degrees. And over here is going to be 180 minus pi 4, which is going to be 3 pi 4. Okay, and it's not a big deal. You can quickly find it on the table. Okay, the sine is the second component. So you are looking for the radical 2 over 2. So the radical 2 over 2, one of them is pi 4, and the radical 2 over 2, the other one is 3 pi 4. Okay, so quickly find out and give us the solution. So the solution is going to be x equal to the pi 4, okay, and x equal to the 3 pi 4, and you're done. Any question? So make sure that when you solve it for sine x, sometimes there is a kind of, technical parts, just don't miss it. For example, this one, you have to rationalize it to see the radical 2 over 2. Okay, any question? So this is going to be type type 1. Okay, getting the type 2. The type 2, I go with the something with the cosine. So the cosine case is going to be, how about 1 plus 1 plus 2 cosine of x equal to the 0. So the unknown in this equation is cosine. So you have to solve for the cosine, okay? So the solution is going to be, you solve for the cosine, it's going to be 2 cosine x equal to the -1, and then the cosine x would be -1/2. Okay, then again, you just check to see where you are going to be, okay? And the cosine is negative. You know that the cosine is going to be negative in the second quadrant and the third one, okay? The cosine. So you have to look for the solutions here. Okay, solutions here. Quickly, we can use it in the table and find out -1/2. Or this is the way I do it. For the positive one, 1/2 is the cosine of the 60 degrees, which is the pi third. So this is the leftover of the pi third, which is a this is 60, so that would be 120, 2 pi third, and over here is going to be 60 plus 180, which is going to be 240. Okay, for the 240, I'm going to have a 4 pi third. Again, you can check it with your table. You are going to be in the second and the third, and the cosine is the first component. You are looking for the -1/2. This is it. You get 2 pi third, and you are looking for the -1/2, which is going to be 4 pi third. Okay, so we can double check quickly, get the result. So this is it. X is equal to the 2 pi third is going to be one solution, and x equal to the 4 pi third is going to be your second solution, and you're done. Any question? That's exactly what you do in calculus, okay? I just give a test yesterday, and this is exactly the equation that they have to solve. Okay, so that's a kind of cosine, but it's a negative. Now the third one is tangent. For the tangent, we give you something that's going to be familiar for you, okay? So we give you a short table, remember, for the 30 degrees and 60 degrees. Just check those, and 45. So these are going to be in this type of format, if you like. Okay. So for the tangent, we go with this one. Suppose you want to solve this equation. Okay, something like 1 minus radical 3 tangent of x equal to the 0. Okay, that's going to be the case. It's a tangent equation. So again, you have to solve for the tangent. So this is going to be the solution. We work for the tangent, so it's going to be negative radical 3 tan of x, okay, is equal to the -1. So you divide by, so it's going to be tangent of x equal to the -1 over negative radical 3. Okay, again, you simplify it into the 1 over radical 3. Remember, no calculator, exact. So you are going to multiply by the radical 3 over radical 3. So we make the top into the radical 3 and the bottom one 3. Okay, so we have the tangent of x. The tangent of x equal to the radical 3 over radical 3 over 3. Okay, going to be the situation we're going to have. For the tangent, you are going to have two solutions again. Okay, the tangent is positive. You know that the tangent is a cosine, sine over cosine. So they must have the same signs. So the tangent is going to be positive here. Okay, and the tangent is going to be positive here. So your angles must be in these two. Radical 3 over 3, we already, we gave you this one before. This is the tangent of the 30 degrees, and you did have it on your test. Okay, radical 3 over 3, tangent of the 30 degrees, which is going to be pi 6. Okay, pi 6, and the other one is going to be here. So it's going to be 180, and the pi 6, 30 degrees, that give you 210, which is going to be 7 pi 6. Okay, so x is equal to the pi 6, and x is equal to the 7 pi 6 is going to be the final answer. There you are. Any question? So this is the group that we call it ordinary. We give you one from each. You see, sine, cosine, tangent. And you have quite a lot in the problems that I have assigned for you from your book. You get these numbers all together. Okay, that's the first group. Question? Now, when we apply these type of ideas in science, sometimes these angles would be different, you see. It's not going to be x, it may be 2x, it may be 3x, x half, it doesn't matter. You just work with this trigonometric form, or the function, if you like, the unknown one first, and then you take care of it. So that's why I'm going to give you another one, another group. It's the way you learn these equations. Okay, so second group. Second group is going to be, that's it. We want to solve each equation for us. Okay, solve each equation. Solve each equation. Just pay attention for the changes that we're going to have. You see, the first one is going to be, we want to solve this equation. The equation is simply sine of 2x. Okay, sine of 2x is equal to the radical 3 over 2. Okay, so the difference between this one and the other one is you don't have x, is it 2x? It doesn't matter. You can call it z. So it's a sine z. Sine z equal to the radical 3 half. So what I'm going to do, you have to go check and to see what is this, okay, what angle would have a sine of the radical 3 half. Okay, so for the solution, this is it. This is the sine of the 2x, which is equal to the radical 3 half. Okay, and you know that the sine, again, your table will find it right away, but the sign is positive, so you are going to be here. Okay, radical 3 half is the sine of the 60 degrees, so it's going to be pi third. Okay, that would be the pi third, and this is going to be 120 because this is 181, and you can have it in your table. So that's going to be 2 pi third. Now, the important part is that, you see, look at this one. When you want to write your solution, you are not going to say that x is equal to pi third or 2 pi third. Your x is 2x now, okay, or it's a z if you like. So make sure that when you write your solution, we say, oh, the solutions are 2x equal to 2x is equal to the pi third. Now you divide by 2. Okay, when you divide by 2, so this means x is equal to the pi 6. So this would be one solution. Okay, so whatever it is here, you can call it z. Z equal to the pi third. But your solution must be x, not z. But what is your z is 2x. 2x equal to the pi third, you divide by 2, so x would be pi 6. Okay, so make sure don't miss this one. The same thing for the second solution, 2x is equal to the 2 pi third. Equal to the 2 pi third, again, you divide by 2. You know that you can simplify these two together. So x would be pi third. And then you're done. Any question? So make sure don't miss it. Whatever it is equal to the pi third or is equal to the 2 pi third. Then you may have an extra job. Your extra job is you have to solve it. Okay, so This is again something that you have to remember. Any question? This is kind of a double angle. You see, some people, they try to substitute the formula for no. You just go ahead, okay? Do whatever you did before, but at the end, it's not x equal to. It's a 2x equal to. So you write the 2x and you solve for x. To solve for x, you have to divide both sides by 2. You divide this one by 2, you get the x. You divide the 1/3 by 2 or 2 pi third, that give you the pi 6. Okay? Any question? Or sometimes it's popular that you may have, that was a 2x, maybe something else, okay? It doesn't matter really. I just go with the popular one. The popular one is this one. You see, suppose you be given 2 cosine. This is also popular. 2 cosine of the x half. 2 cosine of the x half minus radical 2. Minus radical 2 is equal to the, okay, is equal to the 0. Look at this one. Okay. Now again, you see the unknown is cosine. Don't worry about this x half. It's not x. We take care of it. So what we are going to do, we just solve for the unknown solution. So the unknown is going to be 2 cosine. Okay, 2 cosine of the x half is equal to the radical 2. Then you are going to divide both sides by 2. So that gives you cosine of x half is equal to the radical 2 over 2. You see, that's going to be your case. Any question? Now, again, you see, don't bother about x half. It's like z. You are going to solve the cosine equation. To solve the cosine equation, you have to bring this radical 2 over 2 to see what angle would give you radical 2 over 2 again. I'll just give you the circle to know that what's the origin. But you can do it right away. Cosine is positive. So this is the cosine. Okay, cosine is positive. So you have to bring something from the first quadrant and something from the fourth one. In the first one, you will see the pi 4, 45 degrees. So around the circle. So that would be what? And that would be 360 minus pi 4. Which give you, I think it's 315. So basically, this is going to be 7 by 4. Because the 8 by 4 would be 2 pi. Okay, 7 by 4. And you will see it here. You see, this is the first time that you see the radical 2 over 2 for the cosine. And another radical 2 over 2 is, this is it, 7 by 4. Okay, 7 by 4. So that's it. So the solution is going to be, now, when you want to write the solution, you're not going to say x equal to, no, not x equal to, x half equal to. Okay, so you have the solution is going to be x half equal to the pi 4. This is one solution. And the other one is x half is equal to the 7 by 4. Okay, but you want to find the x, this time you multiply by 2 both sides. Okay, multiply both sides by 2. So it's like x equal to, let's say 2 pi 4, which is going to be pi half. Okay, so this is one solution, x equal to the pi half. And over here, you do the same thing. Okay. If you do the same thing, you get the x, and this is going to be something like 14 by 4. Okay, and you simplify it, that gives you 7 pi 2, the other solution. Okay, I just multiplied by 2 first, we just multiply the top. 2 times 7 would be 14, 14 over 4, then we can simplify it and give you the final answer. Okay, any question? So be careful. This is the second group. The second group, the angle is going to be, they call it the multiple angle, if you like. Okay, the multiple angle, it's a 2x, 3x, x half, x4. It doesn't matter. We can take care of it. Okay, so keep the order of your argument, and then you'll be able, to get this one, right away. Okay, any question? So that is the second group. Okay, what's going to be the third group? The third group is quadratic one. Okay, so how about the quadratic one? That's it. So example again, solve each equation. Solve each equation. Quadratic one is, you may have a quadratic in terms of the sign, or you may have quadratic in terms of the, in terms of the cosine. So we talk about a couple of them, okay, the other night. So let's check another one here. This is the one in your book. Okay, this one must be something interesting about it. So what is this? There are other things about this one that I want to explain. You say this is the one. Equal to the 5. These are the one we call them a special one. Let's see what's special about this one. You see you have the square here. Since you have the square here, this is going to be a quadratic one. But in order to be able to solve it, you must only have one type of trigonometric function. You see you have two types. You have the sine and you have the cosine. So the first thing to do is you have to change it. You are going to, you know that the cosine squared is 1 minus sine squared. So we can replace the cosine squared with 1 minus sine squared to change it into the, an equation of one unknown. So this problem would have, it's a double bonus if you like. So you have two operations to consider. It's quadratic. When it's a quadratic, this is cosine squared. This must be cosine, but it's not, it's sine. So you have to change one of them. You cannot change the sine because you don't have any formula for it, but you can change the cosine squared. So the solution of this problem is going to be, this is it. You have a cosine square of x, which is equal to the 1 minus sine square of x. Okay, you can bring all the formulas to the test, to the quiz. Just make sure you use the proper formula. So we go back and we substitute. It's the 4 times cosine square. So it's going to be 4 times cosine square is 1 minus sine square. Okay, minus 4 sine x equal to 5. Okay, now you have to distribute this. Parenthesis is going to be 4 minus 4 sine square of x, and you have the minus 4 sine x, okay, equal to 5. Okay, now what we did, we changed it into the, now it's an equation of a sine, because the unknown must be one of those 4 functions. Now to be able to write it down as a quadratic, you have to subtract the 5, okay, and rewrite this one. You may start with the highest power. So it's going to be negative 4 sine squared, okay, minus 4 sine x, 4 sine x. We have a positive 4 here, a plus 4, and this is going to be minus 5 equal to the 0. Okay, you have to organize it. So we continue. This is going to be negative 4 sine square of x, and this is going to be minus 4 sine x, and this would be minus 1 equal to, equal to 0. Any question? Now this is quadratic. You see it's quadratic in terms of the sign. We talked about the other night, you can replace this one by t, z, u, or just go ahead. It's a quadratic formula, but the unknown is sine x. So we are going to use quadratic formula. Okay, the quadratic formula is going to be, remember, This is quadratic formula. Let's say z, I'm not going to use the x because of this. Okay, is going to be equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. If you feel uncomfortable, you can call sine x equal to the z. Okay, work with the z and come back. It doesn't matter. I just do it, but you don't have to. You see, you may call it z. So your equation is going to be negative 4z squared. Some people, they are more comfortable to use quadratic formula with this new notation. Okay, so it is quadratic. You can stay with the quadratic, but here you have to write sine x, or just go with the z and then go back. So let's find out what is going to be the z is equal to, carefully substitute. Negative b, this is a b, this is a, b, c. Okay, so the negative b would be negative 4 plus or minus the square root of b squared is going to be negative 4 squared. Okay, minus what? 4ac is going to be 4. A is a negative 4. Okay, times the c is a negative 1. Okay, so it's going to be a square minus 4ac. And divided by 2a, this is a 2 times a negative 4. Okay, any question? Go on, carefully simplify it to see if you can get something. So this is going to be equal to, okay, it's going to be equal to that, give you 4. Okay, that give you 4 plus or minus. This is 4 squared, which is going to be 16. And this is also 3 negatives. Okay, 3 negatives. 1, 2, 3. 3 negative would be negative, and 4 times 4, again, is going to be 16. Okay, it's going to be 16. And the bottom one would be negative 8. Okay, now 16 minus 16 would be 0. You're lucky. We get a nice number. Okay, so this is going to be equal to, just wanted to know, it's all right to get this one, a radical 0 over negative 8. Radical 0 would be 0. Okay, a square root of 0 is 0. So what we have, this is going to be 4 over negative 8. You simplify by 4, so that give you negative half. Okay, so z is equal to negative half. Any question? And so, this is going to be the case. What's the question? That we are going to have. Can we bring the equation for the z? You mean the formula for the z? Yes, the formula. The formula for the z, yes. Why not? Somebody asked if you can bring the formula to the quiz. Yes, we don't mind. We need this formula. Okay, but we are not done. This is z. But we are interested in x. So what was z? Z is sine x. Okay, so we are going to substitute, say, oh, z is sine x. Okay, so you're going to have a sine x equal to negative half. Okay, sine x equal to negative half. Now from now on, this is just the ordinary equation. You have to go to the table and find it. The sign is negative. So you look at your table, you get this number. Since the sign is negative, so you are either here, okay, or you are going to be here, because this is cosine and this is going to be your sine. Okay, so you go to the table and you find it. Okay, and the way I do it, for the positive one, it's a sine of the 30 degrees, which is going to be pi 6. So this would be 180 and 30, 210. Okay, so this would be 210, which is 7 pi 6. 7 by 6, and this one over here is going to be 11 11 by 6 to get these numbers. Okay, to get the numbers. What's the question? No, not 270, 330. 11 by 6. 11 by 6 and the 7 by 6. You see, this is the table, and we are looking for the negative half and the second quadrant. Negative half give you 7 by 6 here, okay, and you need one here, and for this one to get the negative, okay, this is it, negative 1/2 is 11 by 6. So it's a 210 and 330 degrees, okay? So there you are. So your x is equal to the 7 by 6, one of them, and your x equal to 11 by 6, the other solution, and you're done. This is a kind of, a complete, okay, it's going to be a complete kind of a solution that we're going to have. Okay, any question? So just make sure to remember the quadratic formula, and then, you can bring it to the quiz and just use it to get these numbers. Okay, and that's one of the problem in your book, in your assignment. And this type of operation is very popular. Just make sure to see, double check if things getting complicated. Probably you miss a sign somewhere. Okay, so if it's going to be on the test, these the square root one must be nice. And so if you won't get it, and then you go back and make sure that when you simplify these numbers, and make sure that you did everything all right to get through it. We give you one. It's very popular in calculus. We use it all over the places, the quadratic one. So it's a quadratic, and the one that you have to change. You have to change because we have the cosine and the, okay, we have the cosine and the sine, okay? We have a cosine and the sine, so we have to change it to get this one through. Okay, any question? So this is a typical one of the type 3. The type 3 that get times to be able to do it. Now, there is another group, quite interesting one, that depends on what are going to do in future. If you're heading for some discipline, like there are cases in physics, and there are cases if you're heading for something like electrical engineering, you have some special trigonometric equation that you have to solve. So these are going to be this group. You see, I don't want to make it difficult. There are, when we talk about, these are ordinary equations. But in a little bit more, if you like, there are a group of 4 types of the equations. We call them classical trigonometric equations. They are quite different from the one that I did so far for you. This next one is one of those classic one. So, this is the only application they're going to have. So this group is very popular for those type of discipline. So pay attention. Okay, so this is it. And you have a number of the nice one in your book. And then I show you a method that you cannot find it in your book. Let me just give you this one first. This is a fairly easy one. Now, what is about this group of the equation that make it interesting? You see, this type of equation, let me write it down. You see, this is it. You want to solve this equation. Sine of x plus cosine x equal to 1. And you want to find the solution. Okay, you want to find the solution between 0 and 2 pi. This group. Now, this group is, you are going to have a combination of sine and a cosine only. Okay, you may have sine x plus 2 cosine x, sine x plus radical 3 cosine x. All of them are going to be of this type. You see, the one that you have a sine and a cosine, you can't do it. Because we should have one one unknown, okay? One of these trigonometric one, either sine or the cosine. So what we did for the other one, you see the other one, we did have a cosine square. Since we have a cosine square, we change it to the sine square and then we get it through. But over here, you don't have that power, okay? You don't have that power. It's not sine square and not cosine square. This is the type that I told you. They call it classic equation, trigonometric equation of type 1, they call it. Now, what you are going to do is you have to create that square to be able to do it. You see, if it's going to be sine square, you change it to the cosine and you get the cosine square, okay? So what you are going to do is you are going to kind of square both sides to get these numbers, okay? But my suggestion is that you just keep one of them, you isolate one of them. You see, you isolate one of these, the sine or the cosine, then you square it. When you square it, you get that square that you are looking for, then you'll be able eventually to change one of them to the other one and be able to do the job, okay? So this is a kind of things that you have to know it, okay? Automatically be able to do it for us. So for the solution, you realize that you have there are some other method to do it, but we just going with the general one. So we find out that if I have sine square, I can change it to the cosine, quadratic, I can solve it. If I had cosine square, then I can change it and do the job. So since I don't have it, this is the trick. I keep the sine here and I move the cosine to the other side. 1 minus cosine x. You see? This is going to be the one. Now square both sides. Okay, why? Because you need a square to be able to do it. You can't do it. Okay, a square both sides, this means it's going to be sine square equal to, this would be 1 minus cosine of x all squared. It depends which one are you keeping to the left, you see, it depends which one are going to keep. So you either end up with the sine or end up with the cosine, okay? And so this is it. Now you have to take care of this one. You have to square it. So it's going to be sine square, okay, equal to, you FOIL it if you like, 1 minus cosine times 1 minus cosine, or just a square of the binomial, which is easy. A square of the first number, which is 1, minus, multiply these three numbers to get 3 terms together, see? 2 cosine times 1, or 2 times 1 is 2, 2 times cosine would be 2 cosine of x. Then plus the square of a second one, which is cosine squared. You see, that's 1. If you feel uncomfortable, 1 minus cosine times 1 minus cosine. I just use this identity. Remember, this is it. If you have a plus b squared, it's going to be a squared plus, you multiply 3 together, see, 2ab. 2ab plus the square of a second one, which is b squared. That's the formula that I use. So 1 squared is just 1. Okay, I'll multiply these 3 together. The sign is negative. I put the negative here. 2 times 1 is 2, 2 cosine, plus the square of a cosine, cosine squared. That's it. You see? Now I have sine square and the cosine square. You see, that's going to be the one. So I need, you know that in order to change it, I need this one. Just look to see which one are going to change. You see, there is a cosine here. Since there's a cosine here, you have to change the sine into the cosine. So everything would be cosine. Okay, so you square it first, then you check to see what you need. Okay, so you need cosine. So what we're going to do, we are going to change this one into the cosine. This is going to be 1 minus cosine square of x. And this is 1 minus 2 cosine of x plus cosine square of x. You see? Eventually, we change everything. We change everything, and then we have Okay, we have the cosine all over the places. So you know that you have to move everything to one side of the equation to be able to solve it. So, you know, you can move these to the left or right, doesn't matter. I'm going to change the sign of these and bring them together. So this is it. It's like moving to the other side. So I already got a 1 minus 2 cosine x plus cosine square of x. Okay, I subtract the 1 and I add the cosine square. X equal to the 0. Okay, you have to switch one of them. Okay, so what I did, I just switched the 1 minus cosine x squared. Now simplify it. Combine the like terms. You have a cosine squared, and the cosine squared would be 2 cosine squared. 2 cosine squared of x. Okay, and this 1 and negative 1 would cancel out. You see? And the leftover is going to be minus 2 cosine x. You see, you get a quadratic equation, but your quadratic is, we call it incomplete, okay? Because there is no constant. You don't need quadratic formula. You can use factoring to solve it, okay? You can use factoring. You can factor out the 2 cosine x, for example, times, this is going to be cosine x minus 1 equal to the 0. Because it's a 0, then you can use the factoring to be able to do it. Most of them would end up with the quadratic equation, of course, but not this one. Okay, so this is it. Now, how are we going to solve this one? You see the product is equal to 0. You know that. You let each one to be equal to 0. Cosine x equal to the 0. So you drop the 2. Cosine x is equal to the 0. Okay, and between 0 and 2 pi, cosine x is going to be 0 at 2 places. If you just look at your table, you will find out that in this case, x is equal to the 0, one solution, and x equal to the pi. So you want the cosine to be 0. The cosine is the first component. You see your first component is going to be 0, okay? To get these numbers, you have it here. Okay, this is 0, and this is going to be the pi, okay, for the cosine and the, okay, oh, I'm sorry, I made a mistake. That's why I cannot find it. Okay, you want the cosine to be 0. Where is the first component to be 0? You see the first component is 0 is here. So this one of them is going to be 90 degrees, pi half, and the other one is going to be 3 pi half. I made a mistake over there. Okay, so one of them is x is equal to the pi half. Okay, so it's a pi half. I rewrite it. Okay, x is equal to the pi half, 90 degrees, one of them, and x equal to the 3 pi half. 90 degree and 270. The cosine are going to be 0. Double check it with your table always. Okay, the cosine is the first component. So the first component is 0 here. This is the cosine. The cosine of the pi half is equal to the 0. And then we see another one here. Okay, 0. So the cosine of the 3 pi half is also 0. 90 degrees and 270. Okay, any question? We're not done. We have 2 parts. Okay, now if cosine of x minus 1, okay, cosine x minus 1 equal to the 0. If this is going to be equal to the 0, then you have a cosine x equal to 1. So you want to find the cosine to be equal to the 1. So if you go with the 1 between 0 and 2 pi, x is going to be equal to the 0 is one of them, and the other one, x is equal to the 2 pi. In your book, they don't write the equality sign here. So if they don't have the equality sign, you cannot use the pi, but usually go with it, for both of them. Okay, so you want the cosine to be equal to the 1. You see cosine is equal to the 1 here, the first component, which is 0. And you just come back again at 2 pi. You know, we just pick one of them. That's why you won't see it here. Okay. So that's going to be 0, and then you go around the circle. So x equal to the 0. You can consider one of your solutions if you like. So basically the solutions are going to be, and this is it, x is equal to the 0, okay, pi half, 3 pi half, and the 2 pi if you accept the 2 pi, you know. But if it's going to be in your book, they don't accept that 2 pi. You see, this is a typical problem which is quite different from the other one that you have to know it. And this is an easy case. You have a couple of them in your assignment, which is different. I'm going to do another one for you so that you know how you handle this. You say this number is 1. It can be any number, okay? If the number is going to be different, when you do this type of operation, you get a little bit more involved, but not difficult, okay? You have 2 in your book. I'm going to do 1 for you. Any question? So be careful. This is one of those cases that typically very popular. Let me just do the one from your review that is a classic one. There are a couple of phenomena. I know that when I teach calculus, that those phenomena are from physics, and most of the time those electrical engineering one, at the end of the day, you end up with one of these equations, then you have to solve it. Okay, then you have to solve it. So just make sure that you are able to solve it. And you have in your review, you have 2 types of problems, and the first group and the second group, which are very technical one. So I do one from those. Okay, any question? So let's see what would happen if you have a real one. So this example is from the review. Tell you that we are going to give you one. Okay, so this is your practice. Okay, your practice quiz number 3. Okay, number 3, and this problem is problem of a 2b. Okay, problem 2b. Problem 2b, you want to solve this equation. Okay, they ask you to solve the equation. Solve each equation. Solve each equation on the interval. On the interval. The interval in question is exactly like your book. You know, that's the alpha, it must be x. X between 0 and 2 pi. Okay. And the one that we are interested in is this famous equation. Sine x minus radical 3 cosine x equal to 1. You see, that is more popular when we get something like radical 3 over here. Not a big deal, not difficult, but you know, you want to make sure you know it, you've seen it, so that you'll be comfortable to handle it. Okay. So it's again that classic equations of type 1 as I talk about it. So the difficulty again is you have the sine and the cosine. You can't do it because you should be able to change one of them to the other one, otherwise you can't do it. So the procedure is going to be, we talk about it, you move one of these to the other side and you square it. And that's very crucial to move, to make it easy for yourself. Just think about it when you want to square it. Okay, let's see. Which one are going to keep, which one are going to move to the other side? This term or the other one? Or which one is easier?
Cosine term?
Which one?
The rad 3 cosine x, add it to the other side?
No. No, you see, just think about the next step.
No, teacher, we move sign.
You
We
see?
move sign. We move sign to other
Yeah,
hand.
the sign is better.
Better.
You see?
Because
You
when we
just,
square it, easier.
yeah, you see, think about the next step. The next step is when you square, remember, there was something became twice of the first time second. If you move the radical 3 to the other side, twice of the first time second, you create 2 radical 3, which is you make it so complicated. So that's why you just isolate the most complicated one. Okay, this is the way we do it. We say isolate the most complicated one. This is going to be complicated because it's a radical 3. Okay, so the solution is going to be, you keep this bad one if you like, and you move the nice one. You see, the nice one. Because as soon as you square both sides, you will lose the radical 3, which is a good thing. But if you move the radical 3 here, you're not going to lose it. You make it so complicated, okay? So make sure that you isolate the one with the radical, okay? Now square it. This is it, the square. Square this one. Now, you see, you square negative radical 3, a square would be 3. And cosine is square. Cosine is square. Now a square of the binomial is going to be a square of the first one, which is 1. Okay? Minus twice of the first times second. 2 times 1 times sine is a 2 sine x. Plus the square of a second one, which is sine square. You see? So keep the radical 3 here so that you'll be able to remove it. Now you know the rest. These are all sine. So we will just change the cosine square into the sine. This always happens the next step. So it's going to be 3 times 1 minus sine square of x is equal to the 1 minus 2 sine x plus sine square of x. Okay, now multiply is going to be 3 minus 3 sine square of x, and this is going to be 1 minus 2 sine x, okay, plus sine square of x. Okay, now move these to the other side if you like. So I'm going to keep those with its sign, because you have to change sign of one of them. So I change these signs, okay? So I change it to the negative 3 plus 3. Sine square of x equals, it's like looking into the mirror, it doesn't matter, okay, which part. But you have to change sign of the one. Move it, okay? Any question? Now simplify it, rewrite it. 1 sine square and the 3 sine square. You say 1 sine square and the 3 sine square would be 4 sine square. So that gives us a 4. Okay, sine squared. And what else? We have a minus 2 sine. 2 sine, and this is going to be 1 minus 3, which is a negative 2. Equal to the 0. You see? Easy equation to solve now. And you can say divide everything by 2 if you like, or factor out the 2, it doesn't matter. Both of them are the same, you know, factoring or dividing the same thing. So this is going to be the case. Okay, then you can divide by 2, or 2 is never 0. Okay, 2 is never 0. So we end up with this equation. You see? Now we have to solve this equation. Any question? So the algebra involved is important to get these done. Okay, so again, you can call it z if you like. Okay, if you bring the z, so your equation is going to be 2z squared minus z minus 1 equal to 0. Even you can factor it if you like. Okay, this can be factored, but I'll go with the quadratic formula just to practice. So negative b, negative 1, plus or minus. So that gives a negative 1 squared minus 4 times AC. So it's going to be 2 times a negative 1 divided by 2a. It's going to be 2 times 2. Okay, so the z is going to be equal to, this is just 1 plus or minus the square root of, this is going to be 1. You have two negatives, negative would be positive, 2 times 4, 8, divided by 4. So that gives you 1 plus or minus radical 9, divided by 4. Radical 9 would be 3. So that gives 1 plus or minus 3 over 4. Any question? Now we have to consider two cases. The case with the positive 1 plus 3 over 4, that gives you 4 over 4, which is 1. So z would be 1. Okay, and the other case is z equal to 1 minus 3 over 4, which is going to be a negative 2 over 4, which is a negative half. So z equal to negative half. Any question? We're not done, remember. Now we have to bring the z, sine x, okay, and then solve the trick equation. That's going to be interesting, okay? So we go for it, and this is it. We know that they remind ourselves that the z is sine x. Okay, so z equal to 1. You're looking for sine x equal to 1. We go to the table and check it, okay, to get the sine. This is only sine of the, okay, 90 degrees. So this would be x equal to the pi half. Okay, you get only one solution for the pi half. Okay, and the other one, so this is one solution. You're not done. You have to check the other one. So the other one is z equal to the negative half. So you get the sine x equal to the negative half, and we did this one. Okay, you know that the negative half, third quadrant and the fourth. So on the third one, x was equal to, okay, 210 and 330. 7 pi 6, 210, 11 pi 6, 330 degrees. So eventually we have three solutions. X equal to pi half. Okay, pi half, 7 pi 6, and the 11 pi 6. You get the final answer. It's a very popular problem in application with the radical 3 that you're going to have, okay? It can be with the radical 3 over 3 too. With the radical 2 over 2 is also, this is again a popular problem that we able, be able to do it. Any question? So make sure that you are able to get through this type if you are interested in this very interesting point, or type if you like. And we want to make sure you know it. In your book, again, there is another one, the practice one is from your book. Sometimes they don't give you this directly. They give you in terms of the sine, secant, tangent, but you have to do a little bit to be able to get it. I'm going to do that one for you too, because you have two in your book, and one of them is your assignment. I just do this one, or just make sure you know it. Any question? So just rewrite this group. As I told you, this group are popular, not bad, a little bit technical, and be able, to do it right away. Okay, I know a shortcut that I do myself. I give you that shortcut later to see the way. There is a formula for all of them when they do it in in the application cases that we're going to use for engineering, but we don't want to give you those formula. We would like you to practice. And that's why we stay with this one. But there is another group of this format, but you do a little bit to get it. So that's a 2D in that review. 2D. The rest of the problem are just straightforward, but these are the one that we are going to be interested in. A 2D is this one, okay? You have a secant of x minus. Sometimes they give you the problem in this format. Minus a tangent of x. Tangent of x equal to the radical 3 over 3. To show you that this is a kind of a same thing. Okay, this is what we have. Now, again, the equation that we are going to solve, you know that we solve the equation, if you like, sine and cosine, or we would like to have only one. Okay, we would like to have only one trig function. So if you see the second tangent, you better change them to see if it's getting better. So what we are going to do is we just change it because we are more familiar with the sine and the cosine. Okay, so you change the secant, you know that the secant is what? Is 1 over cosine. Okay, and the tangent is going to be sine over cosine. Is a simplification is like one of the identity that you did have on that quiz. Okay, now what we can do, find the common denominator.
Yes, common denominator.
Cosine x, and on the top is going to be 1 minus sine x. And this is going to be what? Radical 3 over 3. Okay, now cross multiply. You know that in algebra, if you want to solve an equation, you have to get rid of the denominator first. So cross multiply 3 times, radical 3 times. Okay, it's going to be 3 times 1 minus sine x. And on the other side would be radical 3 times cosine x. Okay, now continue. Is a 3 minus 3 sine x. Okay, and this is going to be radical 3 cosine x. You see? That's a type that we talk about it. I mean, you can move the sign to the other side, but this would be good if you just keep it as is. Yes. Okay, you have the radical, you have the sine and a cosine. It's not sine square, it's not cosine square. Remember, you have to square both sides. Yes. So in this case, the radical 3 cosine x has already been nicely isolated. So we are not going to move it to the other side. Okay, then we square both sides. Okay, 3 minus 3 sine x. It's similar to the one that we did, but a little bit different. Squared. Radical 3 cosine x squared. Okay. Now the same story. A square of the first one, 9 minus. You multiply these 3 numbers together. See, 1, 2, 3. 2 times 3 would be 6. 6 times 3 would be 18 sine x. And plus the square of a second one, which is going to be plus 9 sine squared. Okay, now we square the radical 3, we get the 3. And we square the cosine, we get cosine squared. Okay, this is it. Again, there is a sign here. So you have to change the cosine square into the 1 minus sine squared. So it's going to be 1 minus 18 sine x. Okay, plus 9 sine square of x is equal to the 3 times. They change this one into the 1 minus sine squared. Okay, then again, you have to do the algebra. 9 minus 18 sine x plus 9 sine square of x. And this is going to be 3 minus 3 sine squared. Okay?
Yeah.
Now start collecting to one side.
Mhm.
I'm going to change the sign, bring them here. So I have the 9 minus 18 sine x plus the 9 sine square of x is going to be minus 3 plus 3 sine square of x, you see, equal to the 0. Now combine the like terms.
Yeah.
We have a 9 sine square and the 3 sine square making to the 12. Okay. So that's 12. In case of the sine, we have only minus 18 sine x. Okay. So minus 18 sine x, and this is going to be 9 minus 3, which is going to be a positive 6,
Mhm.
equal to the 0. Any question?
We divide them from 6.
Okay. So we can, yes, we have the factor 6 out, and then we just substitute for the z to take care of it. Okay, take out the 6. Take out the c, we get, very similar equation that we did. Is minus 3 sine x, and this is going to be plus 1. Again, this is a factor. This is exactly, so 6 is not 0. We're going to remove the 6, so it's going to be 2 sine square of x minus 3 sine x plus 1 equal to, okay, equal to the 0. Okay, it's almost similar, but it's not the same exactly like the one we did. So we go with the z mode. This is it. Z equal to the sine x. So we are going to have a 2z squared minus 3z plus 1 equal to the 0. You can factor it right away if you like to get these numbers, or just a quadratic formula. Okay, to get the numbers, I'll show you factoring in case you like it.
Yes.
It's going to be z minus 1, okay, times 2z plus 1. See, because, sorry, 2z minus 1. Because negative 1 times negative 1 would be a positive 1 here.
Mhm.
Okay, so, if you get a chance, you can factor it. So we get two solutions. Z minus 1 equal to the 0. That gives z equal to 1. One solution. And 2z minus 1 equal to the 0. That gives you 2z equal to 1. So z would be 1/2. Okay, any question? So, this is nice factorable. So we factor, you see, algebra is very much involved, but not bad. Now we are going to find the, remember, you're not done. You have to find the x. So you start with the fact that the z equal to 1 means sine x equal to the 1. To the table, you get only one angle, pi half. Okay, z equal to the half. Z equal to the half, that give you, okay, that give you sine x e to the half. And you know that the half is going to be sine of the 30 degrees, which is the pi 6. You want the sign to be positive, you are either in the first quadrant and the second, and x equal to, that's a 30 degrees and 150 degrees, which is 5/6. Okay, so eventually the solution of this equation is x equal to the, okay, x equal to the pi half, and x equal to the pi half, pi 6, and the 5/6. This would be your three solution. Okay, so this is, I told you, it's unavoidable. Most of the nice cases, okay, would end up with this quadratic one. You start with something which is different. This is in your assignment of that section that I assigned. I think it's problem number 3. That you have to know that, just change it. When we get this quadratic one, we have to know that we have to square it to be able, to get through this problem. Okay, so that is solving the equations. Okay, trigonometric equation to get these numbers done. Okay, any question? So what I would like to do, I would like to give you a little bit about the complex numbers. Then we can go on and get more problems, okay, or more example. I'll give you a break. So we come back and just introduction to the complex numbers and how we're going to relate it to the, okay, there is going to be, we review it, the one that you have to know for the algebra, but we are going to be interested in the trigonometric part, okay? So we change it into the trigonometric part, okay? So give it 10 minutes, then we come back and we take a very just introduction to the complex numbers for the time being, so that be able to get through this quiz, and then trigonometric function, these complex numbers can be used to solve okay, equations. Equations that you solve so far are easy, you know, quadratic, at most quadratic. But if you are going to do something in future, you know, in again disciplines like physics, especially physics and engineering, you should be able to solve the equation of the higher degrees. And there is a theorem in algebra that tell you that every equation would have a solution. So there is no case that your equation won't have a solution. But you have to believe in complex numbers to be able to find the solutions. And these topics that we're going to talk about it show you how we're going to do, how we're going to solve those type of equations. There are 2 different courses that if you go on in future, okay, if you want to, you know, to go to the engineering discipline or physics, there's one course we call it differential equation. In that course, you need this idea that I'm going to talk about it. In calculus, a very mild one. In calculus 2, we are going to use it. So why not? We're going to give you an introduction over here about that one, okay? We are done with the chapter 6. We are not going to do anything for the time being. Chapter 7, we go with the 8 first, because 8 is connected to what we did here. 7 is quite different. Okay, so we got 10 minutes. We come back and we give you introduction to the complex numbers and trigonometric functions. That's it. See you in 10 minutes. So I just want to close this camera. Okay. So we are going to talk about complex numbers. Okay. Just to remind you from the past, in case just refreshing your memory, and then we quickly change it into the format that we are going to use in application problems. So this is going to be part of chapter 8. Okay, so 8.1. Just go over a couple of these section. In 8.1 is just a introduction. Okay, so this is it, and we just work on this chapter first, complex numbers. Then the leftover, whatever we have time, we come back to the chapter 7. Chapter 7 is something like the one that we did before. If a triangle is given to you, then you can solve it, which means you're going to find the angles and the length. Okay, in general. We did it for the right triangle. We didn't did it for an arbitrary triangle. Then we get to that one. Okay, so 8.1 is complex numbers. Okay, complex numbers. We go with the algebra first. Okay, whatever we know about it, and then we change it to the new format. There you are. You know that if let's say x and y are going to be real numbers, then a number of the form of x plus I y is going to be called a complex numbers. A complex number. Okay, where you know that this I is the one we call it imaginary units, is a number that is a square is equal to the -1. Because when you work with the real numbers, a square of each number is positive. But in the case of the I, we just introduce these numbers, you get it equal to the I square equal to the -1. I is going to be called, the imaginary unit. Okay, so this is going to be the complex numbers. So if z is equal to the x plus iy, if this is a complex numbers, it's going to be a complex number, then x is called the real part, is called the real part, and y is going to be called, the imaginary part, or the complex part. Imaginary part of z. Okay, there's a notation that we use, but we are not going to use it quite a lot, but we write it on. So we write, if you like, x equal to the real part, re of z, real part, and y is equal to imaginary part of z. Okay, so this is a standard format of a complex numbers. Okay, so for example, if they give you, if we given a complex numbers, if z is equal to the 2 minus 3i, okay, then x is equal to 2, the real part, and y is equal to -3. Okay, or if you like, and so the real part of z is equal to 2 and imaginary part, okay, of z is equal to -3. Any question?
Sure.
Now, if z is equal to the 5i, what is the real part of z?
0
0. And the imaginary part
is
is 5.
5.
Okay,
5.
that's going to be, okay, this is going to be then, because we need these in future. Okay, the real part of z is 0, and the imaginary part of z is equal to 5. You know, you can think about it, you know, this is it, you know, just for your see, you can write the z as 0 plus 5i. So the real part is 0, imaginary part is 5. Okay, so we can have this type of numbers. Any question? Or if z is equal to the -7. Okay, what's the real part?
Part -7.
The part is -7, and the imaginary part
0.
0. You know that z equal to -7 is a real number. Okay, every real number can be also considered as a complex number. Okay, so z equal to the -7 is a real number. Okay. Now we are interested in operation with the real numbers. You see, the idea of this is the introduction of a complex numbers into this format is that you see each complex numbers over here. Each complex numbers can be considered as a pair of points, if you like. Can be considered an order pair, if you like. Consider as a point that the x coordinate of the point is equal to the 2, which is the real part, and the y coordinate is -3. So we have x equal to 2 and y equal to -3, if you like. So what we can do is we can find a format of a complex numbers, which is called, we call trigonometric format. So the trigonometric format would be, eventually this is what we are interested in. It would be easier to handle for the complex numbers. But in this section, for the time being, we just get to know the operation that we can do. This is like ordinary numbers. You can add, subtract, multiply, and divide. So we are just give you one question and you're just doing this operation for us. So let's see what type of operations we have. Operations. Okay, on complex numbers or with complex numbers. Complex numbers. So if you want to add, subtract, multiply, we treat them as an algebraic expression, if you like. Okay, you know that algebraic expression, if you want to add, you combine the like terms. If you want to multiply, you multiply. You may use, FOIL method, etc. But the division is different. So I'll just give you some examples one by one, and then we get to the division. Okay, so the example is going to be, we want to simplify, we say, okay, or just perform, simplify. Simplify each expression, and write the result in a standard form, if you like, and write your answer okay, in the form, we call it a standard form of x plus iy. Okay, this is the one we refer to it as a standard form. A standard form. Okay, let's get this one. So it's going to be addition, subtraction, multiplication. So the first one is, suppose you are going to add 1 plus 5i. You would like to add it to the -2. Okay, -2 minus 3i. See, like in algebra,
Very good.
you combine the like terms, or you
Yes.
can drop the parentheses, combine the like terms. Okay, so the solution is going to be, so it's going to be equal to, if you like, you can drop the parentheses. It's going to be 1 plus 5i minus 2 minus 3i. You combine the like term, you start with the real parts, okay? 1 minus -2, that gives you a -1. And the complex part, we have the 5i minus 3i. 5i minus 3i would be plus 2i. Okay, so this is, it's done. And this is, we call it a standard form. Any question? Okay, so that's addition. Addition, it doesn't matter if you want to add any two quantities. You can add the quantities of the same kind. Kind in this case is going to be real types and the complex types. Okay, so that's a type 1. Another one is going to be, suppose you want to operate 7i minus, okay, minus 2 plus 10i. It's a kind of subtraction over here. You know that you just apply the negative sign inside. Okay, so the solution in this case is going to be equal to the 7i. Okay, it's going to be minus 2 and the minus 10i. Again, you combine the like terms, start with the real part, it's a -2. So this is going to be a -2, and the complex part, 7i minus 10i, that give you minus 3i. So that give you the numbers. Must be in the standard form. Okay, that's a subtraction, if you like. Okay, the next part is going to be multiplication, which is multiply. Okay, suppose you want to multiply 2i times 3 minus 4i. You distribute it. Okay, just use the distribution. You multiply, you go forward. Okay, so the solution is going to be, we have the 2i times 3 minus 4i. It's going to be equal to, you multiply, you go forward, 2 times 3, 6, 6i. Positive negative would be negative, 2 times 4, 8, 8i squared.
Yes.
And you have to simplify it, you change the
I
I
square.
to -1.
-1, yes.
So it's going to be 6i minus 8 times a -1. So the negative would be positive, so that gives 6i plus 8. But
Yes.
the standard form is you switch it,
Yes.
8
8.
plus 6i. So that would be the final answer. Okay, so you multiply it. If you get a chance, any I squared, okay, so you replace by a -1. And then you write in standard form. Okay, any question? Now, another one is, you may have to use the FOIL method. Okay, suppose you want to multiply 2 plus 3i times, okay, times a -5 plus 2i. Okay, you FOIL it. You find, use the find method as we did with the ordinary algebraic expressions, and then we simplify.
Yes.
So it is going to be equal to, you see the solution is going to be equal to violet. You multiply the 2 first, and then you come back and you multiply 3i. So 2 times the -5 would be -10. Okay, 2 times 2 would be 4. That makes it to the 4i. Then we go inside, 3i, positive negative would be negative, minus 15i. Okay, you move on. Positive would be positive. 2 times 3 would be 6. So that gives us 6i squared. Okay, usual find method. You combine the i's here. Let's see, this is going to be a -10. So we have the 4i minus 15i, it's going to be -11i. Now we change the i squared into the -1. So it's going to be plus 6 times a -1. Okay, so for the i's, you just combine the like terms together, and the I squared is -1. You move on, this is going to be a -10 minus 11i, and this is going to be -6. Now we get the chance to go on, simplify again. -10 and -6 would be -16 minus 11i, the final answer. Okay, then it's just, just using the FOIL method. You will see later that this type of operation, we do it, and we are going to use trigonometric form, and things would be so easy to handle, okay? We just wanted to remind you what we do now, and then we do it later. Okay, so that's a multiplication. Any question?
No.
No, the division is different. Now, let's just give you one more of this to prepare for the division. You see, if you have something like 5 plus 3i times 5 minus 3i. You see, this is the one in algebra, we call it a special product,
Yes.
because it's like a plus b times a minus b.
25 minus 9. 9 we multiply with I square. I
That's it,
square.
Yeah,
We
then we can
change it to -1.
Yeah, that's correct. So basically, this is the one that we are going to use, okay? So it's a plus b times a minus b. Just remind you, you see a plus b times a minus b. This is going to be always a squared minus b squared. Okay, so the solution is going to be, I rewrite it because I wanted, 5 plus 3i times 5 minus 3i. So 5 times 5 would be 25, and minus 9i squared. I squared is a -1. So it's going to be 25 minus 9 times a -1. So that would be 25 plus 9, which is going to be 34. You see, the advantage of this operation is that they are complex numbers. And when you multiply them together, we get a real number. That is something that we are going to use in order to get the division of a complex numbers. Because you know that in mathematics, if you want to divide, you can divide by whole numbers only. You see, if I give you a pizza, you can divide it by 2, by 3. But if I ask you to divide the pizza by 5 plus 3i, doesn't make sense. Okay, so we are going to use this type of ideas. We know that, 5 plus 3i, that's the conjugate of the 5 plus 3i, 5 minus 3i. So this means if you multiply a complex number by its conjugate, multiply by its conjugate, the result is a real number. And this is the one that we are going to use, okay? So that is the idea for number 6.
Okay.
Number 6 is you want to get this one, okay? You have 1 plus 2i. You want to divide it by 1 minus 5i. You see, as long as this is in terms of the I, you can't do it. Because the division must be done by whole number. Remember, if it's a radical,
Multiply.
we rationalize it, okay? It's the same thing. So what we're going to do is,
We
we're going to
multiply.
multiply the top and the bottom by
Mhm.
the conjugate of the bottom. This is 1 minus 5i. We multiply by 1 plus 5i. Why? Because if you multiply these two together,
Instead
the
of
result would be a
the
number,
denominator.
okay?
Mhm.
So it's like when you want to divide by a radical 2, you can't do it. You have to rationalize it. Okay, so the solution is going to be, so you start with the given one, which is 1 plus 2i over 1 minus 5i. So what I do is I just repeat it. So I multiply the top and the bottom. You see this is 1 plus 2i. I'm going to multiply by the conjugate of the denominator. This is 1 minus 5i would be 1 plus 5i. Okay, we do the same thing here. That would be 1 minus 5i. We multiply by 1 plus 5i. Okay, because quickly the denominator can be taken care of. It's a special product. It's going to be 1 minus, you see 5i times 5i, which is 25i squared. Okay, it's a squared minus b squared. A squared is a 1 squared, which is 1. 5i squared will be 25i squared. On the top, we have to FOIL it. Okay, apply the FOIL method to the top to simplify it. You multiply the 1 first, that give you 1 plus 5i. Okay, then you multiply the 2i. 2i times 1 would be a 2i. Okay, 2i times 5i would be 10i squared. 10i squared. Okay, any question? Now simplify it. It's going to be equal to the bottom one. This is going to be 1. I squared is a negative 1, so that makes it a negative positive. So that will be plus 25. Okay, the top, we get the 1. You have the 5i and 2i would be 7i. So that gives 7i. But this is 10i squared. You replace the I squared by negative 1. So that makes this one into the negative 10. Okay, so we combine the i's. 5 and the 2 would be 7. We replace the I squared by negative 1. So it's going to be 10 times negative 1, which is a negative 10. Or negative 25 times negative 1, which is going to be positive 25. So we continue to simplify it. So the bottom one would be 26. The top is going to be 1 minus 10, which is going to be a negative 9, plus 7i. You see? Now we can divide. You're not done because the complex numbers, remember, you need a standard form. So it's going to be equal to, the first part would be negative 9 divided by 26. That's a real part. And the second part is going to be plus 7 over 26i. So that give you the final answer, the result of the number into the complex form. Any question? So these are operation with the algebraic operation, if you like, ordinary one that we do with the complex numbers. Be careful about the division. The multiplication is easy, but we can change it into the so-called trigonometric one and take care of it. So that was just refreshing your memory. Any question? Now, you see, the way we are going to use the complex numbers, we are going to be very much interested in the powers of the complex numbers for solving those equations. So for example, if you have 5 plus 3i, if you want to square it, it's easy. Even to the third cubic, it's easy. But if I give you this one to the power of 100, 2000, you can't do it. So in order to be able to do this type of operation, we have a so-called trigonometric form or the polar form of the complex numbers, okay? So this is the one that we're going to talk about it. That was 8.1, which is just the warm-up. We give you one question, just doing a couple of these operations for us, but we are interested in the trigonometric form, okay? Let's see what is going to be trigonometric form of the complex, okay, a complex numbers. They call it polar form or just a trigonometric form of the complex numbers. Okay, so this is going to be 8.2 polar form. So polar form or trigonometric form. Trigonometric metric form of a complex numbers. Of a complex number. And that is what, it's make it so popular for the complex numbers, okay, to see. Let's say I'm going to change it into the polar form. Okay, are you ready? Quite an interesting argument. Most of the application of the complex numbers are going to be done through this polar form. Okay, so there you are. Suppose you give me a complex numbers, okay? Suppose z equal to x plus iy, okay, is a given complex numbers. Complex number. Okay, that's going to be the one. Okay, then if you like, then z can be considered. Z can be considered as a point, okay, with the coordinates, with, okay, it can be considered as a point, let's say, x comma y. Okay, x comma y on the coordinate system, if you like, on the coordinate system. So what is this one? You see, this is the one that we usually say x-axis and the y-axis. So what we're going to do, instead of the x-axis, we're going to call this one a real axis. Okay, because x is the real part, remember? X is the real part, and the y is the complex part. So we are going to call this one a real axis, okay? Real axis, or just the x-axis. And this is the one we call it imaginary. Imaginary axis. Okay, we would like to bring geometry. Okay, bring geometry to take care of this one. So what we are going to have is this is x. Okay, and suppose this is y. So what is going to be, where is going to be z? You see, in order to identify this is going to be z. Okay, this is going to be your z. Z you can write down as x and the y, or you can call it x plus I y if you like. Okay, so if you give me a complex numbers, I can put it on these xy coordinates. These xy coordinates, we are going to give us a name. Remember, when using for the real numbers, we just call it rectangular coordinate system. But over here, we call it complex plane. Complex plane. Complex plane is going to be where you can, okay, you can locate, if you like, okay, you can locate all your complex numbers. Okay, so that would enable you to bring the problem from geometry, if you like, into the complex numbers. Okay, so we can identify each complex numbers on the coordinate system. Let me give you an example. Okay, the example is would like you to locate each complex number on the complex plane. Complex plane, since it's a two-dimensional, we call it a plane. It's like the one that you did in algebra, right? The new format. You see the first one, z equal to the 1 plus 2i. So quickly, you know, your x is equal to 1. You see, x is equal to the 1 and y is equal to 2. So that would represent the point 1 and 2. Okay, so the solution is going to be, you claim that the x is equal to 1, y is equal to 2. So you are simply identifying the point 1 and 2. So this is it. We call it R for the real, I for the imaginary. And we identify the point, and this is it. X is equal to 1, y is equal to 2. So this would be your z. So this point would be represented by, okay, this is the point 1 plus 2i, if you like. Or just z equal to the 1, 1, 2. Both of them are going to be the same thing. 1, 2. Okay, so it's going to be x, and this is going to be y. Any question? You can be in the first quadrant, the second, the third. So give you another one. If they give you something like z is equal to, okay, z equal to the 3 minus 5i. If you want to identify this, solution would be what? What is x? X is equal to 3. And the y is equal to negative 5. So what is your point?
3.
Okay, x equal to 3. This is it. 1, 2, 3. And the y is negative 5. So it's going to be 1, 2, 3, 4, 5. So this is going to be your point here. Okay, the point you can say 3. Okay, this is the point 3 minus 5i, which is the same as the 3 and negative 5. Okay, so it's a kind of new format or new geometry that you're going to have. Okay, and we use it quite a lot. Give you another one. Any question? So give you another one. You should have this one. How about z equal to the negative 2i?
Oh, yes.
Okay. So how
No
about
real number.
what is x?
0.
X is equal to the 0 and y is equal to the negative 2. So your point is going to be, this is the real part and this is the imaginary part. So your point x is equal to the 0, nothing on the real axis. Y equal to the negative 2, so 2 units on the, okay, 2 units here. So this point would be negative 2i. Z equal to negative 2i. Okay, so it's the same thing that you did for the, for the algebra. So you have this type of, a similar idea for the point. Okay, any question?
No.
Now we are going to be able to give you a definition of the complex form, the polar form, okay, of the complex numbers. There you are. Let's see what's going to be a definition of the complex form or the polar form of a complex numbers. Now, look at this one again. You see, if a z is given to you, if you have a complex numbers, okay, suppose this is going to be your x and the y as we did it. So this is x and this is y. So this point would be represented by z equal to the x plus I y. So we want to just write it down as a geometrical format. You see, if you connect this line to the origin, if you connect it to the origin and call this angle, okay, we call this angle theta, if you like, theta. So what you have a right triangle here. You write a right triangle, so this is going to be x, and this is going to be y at the same time. So we get the right triangle and the legs, you know, the x and the y. You know, this is going to be the sides of the right triangle. And you are going to call this one r. Okay, and we can find it. You know that r squared would be x squared plus y squared. Okay, so what we can do is we can use the trigonometric function to define this, to find the x and the y, if you like. So if you consider the, okay, it's the same thing that we did for the introduction of this trigonometric function. So if you find the sine of the data is opposite side, y over r. And if you find the cosine of the data would be x over r. So we can find it. You see, this is going to be the one. So this x is the adjacent one. X is going to be equal to the r cosine of the data. Okay, that's going to be your x. And the y would be the, the opposite side. It's going to be r sine of the data. Okay, it's like finding it that use cross multiplication to get it. You see, the sine of the data would be y divided by r. So y would be r sine of the data. Cosine of the data would be what? Would be x divided by r. So if you cross multiply, we get the y equal to the r sine of the data. Okay. So what was that? Z. So your z was equal. I write it down here, then I give you the full definition. You see, your x is going to be r cosine of theta. Your y would be r sine of the theta. You see? Now what's going to be your z? Z is what? Z is x plus iy. Substitute. X would be r cosine of theta plus I times IR sine of the data. If you factor out the R, Z would be R times cosine of theta plus I sine of theta. You see, this is going to be called trigonometric form or polar form of a complex numbers. Okay, so this condition over here, it is going to be trigonometric, or polar form. polar form of the, okay, of Z, if you like. So that make it into the definition that we are going to be interested in. So the definition that we created is that if Z is equal to the X plus IY is a complex numbers, is going to be a complex number, complex numbers, then Z equal to R times cosine of the data plus I sine of the data, okay, is going to be, okay, is the polar form. In your book, mostly they call it polar form, but we call it also trigonometric one. Okay, Z equal to the R cosine of theta plus I sine beta is the polar form. Okay, the polar form of the complex numbers, of the complex, okay, complex number Z. And it's just the beginning, really. This is going to be, there is going to be a connection between complex numbers and the real numbers in calculus. That collection is coming from this one. Okay, this format that you will see over here. It was done by Euler for the first time. Okay, so if Z is equal to the X plus IY is the complex numbers, then Z equal to the R cosine of theta plus I sine theta is going to be called a polar form. Now, just note that as we talk about it, note that we talk about the X and the Y. What is this R? This R is coming from here. It's going to be the hypotenuse over here, okay? So this is going to be, note that the R is going to be equal to the positive square root. A square root of X squared plus Y squared. Okay, yes, sometimes we denote this one by the, okay, absolute value of Z, or we are going to call it, is going to be, is called, okay, it's called the, as a vector, we call it a magnitude, okay, the length, okay, magnitude of Z, okay, that's going to be the one, and the angle data that you're going to have, okay, and the angle, the data which is going to be between 0 and 2 pi. Okay, in your book they don't write the equality sign. It's okay, you can do that one too. This is going to be called, okay, is going to be called, we call it the, okay, we call it the argument, okay, of Z. So you should be able to find the R and the, okay, R and the data all the time. R is easy, you find it is going to be square root of X squared plus Y squared. In order to find the data, again, you note that, you see, note that, remember X is equal to the R cosine of the data, Y is equal to the R sine of the data, or just in this, okay, in this right triangle. If you find the tangent, because X and the Y would be given to you, you want to find the data. So you see, X and the Y is the opposite side and the adjacent. So we can use tangent. Tangent of theta is the opposite over the adjacent one. So note that tangent of theta is equal to the Y over X. So in order to change it into the polar form, you have to use these two formula. okay? So they usually give you Z and they ask you to write it down in polar form. So you have to find the X and the data. Of course, you know that this tangent is what? Tangent is a periodic function, and you are going to have many, many solutions, but you're going to find only one data between 0 and 2 pi to get these numbers. Okay, your job for the time being is we give you the complex numbers, and then you write the polar form for us, because we would like to do all those operations that we talk about it, especially multiplication and the division with complex numbers in polar form. So you have to change it to the polar form first for us. Okay, any question? So that's a very nice interpretation of the complex numbers that you haven't done it in algebra, because in algebra you didn't have these tools. Okay, but now that we have the trigonometric functions, be able to talk about it. So let's find out how we're going to write down this this polar form for us. Give one question, a couple of them, of course, to find the polar form. Okay, so this is your job. Example would like you to find find the polar form. The polar form of each complex number. Okay, polar form of each complex numbers. Let's go with the first one. And the complex numbers is Z equal to 1 plus I. And this is the way you do it. You identify the X and the Y first. Okay, what is X and the Y?
X1, Y1.
Okay, that's it. Okay, X is equal to 1, Y is equal to 1. Okay, in which quadrant this number is going to be?
The first one.
The first one. It would be useful, not for this one, but for future. Okay, so the number is here. So we have the X and the Y. Okay, this is it. If you like, you know, this is the number, 1 plus I. Okay, so you have to find the R first. So R is equal to the square root of X squared plus Y squared. So in this case, it's going to be 1 squared. And the 1 squared is going to be 1 plus 1, which is a radical 2. Remember, you are not going to use your calculator. These numbers must be exact. So it's a radical 2. That's fine. Okay, that's going to be R. Any question? You have to find the data. Tangent of data is equal to the Y over X. Y over X, that gives you 1, 1, okay, which is equal to 1. So the tangent of theta is equal to 1. Okay, then you go on the XY coordinate. Okay, you go with the lucky unit circle. You find the data between, it must be a unique number, not two numbers. Okay, you know that if you go to the circle and identify it, your data is going to be pi 4, 45 degrees. Okay, so since it must be consistent with the position of your point is in the first quadrant and data is pi 4. So that's good. Okay, now we're going to write it down. The polar form Z equal to R times cosine of the data plus I sine of the data. Then you substitute. So the number was 1 plus I is equal to R is radical 2 times cosine of the pi 4 plus I times sine of the pi 4. This is going to be the polar form of your number. If you substitute, simplify this one, you must get 1 plus I. Okay? So this is the way we're going to do it. It's important to get the data. I'm going to give you another example to see what's the difficulty. So this is the way you are going to do it for us. It's straightforward. X and the Y is given to you. You just substitute in this formula. So that gives radical x squared plus y squared, which is radical 2. Nice. Then in order to find the data, tangent of data is 1 over x, y over x. You get a 1. Just be careful when you pick the number for the data. Check to see in which quadrant are you located. It's the first quadrant, the tangent is positive here, so it's going to be pi 4 to get these numbers, okay? Because if you have something here, you see, if you have something here, again, you may get tangent equal to the 1, because this is negative, which is going to be positive. So you must identify where are you. Okay, I'll show you in a minute, okay, to get the numbers. Any question? When you are in physics or this engineering one, they have a brief format for this formula. So I show you, and in case we see it and we can use it, or they write 1 plus I, they write the radical 2, but for the rest, they just use the abbreviation. They write CIS up by 4. Okay, so if you see somewhere, or you can use it if you like, we don't mind. So if you write radical 2 CIS up by 4, you mean a radical 2 times cosine of the pi 4 plus I times sine of the pi 4. Okay, so we accept it if you write it down. Any question? Give you another one. So another one is, this is very similar to what you have in your book probably. Z equal to radical 3 minus I. Okay, solution. Identify the x and the y. So there you are, z equal to the radical 3 minus I. So your x is a radical 3. Your y is a negative 1. Check to see where you are. X positive, y negative, you are here. Okay, that would be useful when you want to pick the proper angle. Okay, and so we go for it, find the r first. Okay, what's going to be r? R is equal to the square root of x squared plus y squared. Substitute. X is a radical 3 squared plus 1 squared. Radical 3 squared would be 3. 1 squared is 1. So that gives a radical 4, which is equal to 2. Remember, r is the length, so it's positive all the time. Okay, that's going to be your r. You have to find the, okay, you have to find the data. So to find the data, we go with the tangent of the data, okay? Get the tangent of the data, which is going to be equal to the y over x. Okay, the y is a negative 1. Okay, negative 1 over x, which is the radical 3. You know that you have to rationalize it. That gives a negative radical 3 over 3. Now you have to find the angle. Okay, what angle is going to be okay, appropriate for this one. So what we are going to do is For the positive one, radical 3 over 3 is a tangent of the 30 degrees. Okay, it's going to be tangent of the 30 degrees. So negative radical 3 over 3 is negative. Tangent can be negative in the second quadrant or in the fourth one. So since the positive one is 30 degrees, okay, so you have to come here. So this is 360 degrees, okay. So 30 out, so that give you 330, 11 by 6. Remember, you cannot use a negative one. Some people, they use the negative angle and negative pi 6, which is not correct because the angle must be positive between 0 and 2 pi, okay? So be careful. So this will tell you that the data is going to be 11 by 6. 11 pi by 6. This is the part that when it's a negative, you got to be careful. You have to check to see where your point is, okay? So radical 3 over 3 is the tangent of the 30 degrees here. So you want to make it negative, you have two options, here or here. So you want to be here. So it's a 30 degrees, you go around the circle 360, 30 out, 11 by 6, okay? So that's going to be 11 by 6. Now we are ready to give you the result. So R is equal to 2 and the 11 by 6. So this is the final answer. You say that the radical 3 minus I, okay, is equal to what? Is equal to 2 times. You can say that CIS right away, or 2 times the cosine of 11 by 6, 11 by 6 plus I sine of 11 by 6. Or if you like, in short, we accept it. 2 CIS of 11 by 6. That would be, okay, that would be polar form of the given numbers. Okay, any question? So for operations that we're going to do quite a lot, okay, we are not going to give you that one tonight. It depends on this polar form. So just make sure you get it all right. We have a couple of them in your practice one that I posted. So let's take care of that one. Okay, question number 3 on that. Okay, question number 3 on the practice quiz is the polar form of a complex numbers. So let's do that one. Okay, so these examples are going to be from example. That's your practice quiz number 3. Practice quiz number 3, and this is problem number 3. Problem number 3 would like you to write each complex numbers. Okay, write each complex number, in polar form. Number in polar form. And this is it. You have the first one is 2 plus radical 3i. I write all of them, then I do it. And the part B is, there are just all the 4 possibilities are here, so that you know how to handle these type of problems. And we give a couple of them as one question. So that's 4 different cases, or 4 possible. Okay, are you ready? Start with the first one. So the solution is going to be, I just want to make sure that this is all right. Maybe that first number must be changed. We have, okay, so this is it. This must be also 3. Because otherwise you have to go and get some decimal numbers. Okay, so this is going to be the case. So it's a 3 plus radical 3i, the first one. And so this is the way we are going to do it. Solution, part 1. Okay, this is going to be the part 1. The part 1, z is equal to, okay, z is equal to the 3 plus radical 3i. And that is going to be the case. You identify the x and the y. So your x is equal to 3 and your y is equal to the radical 3. This is the first step. You identify the location that you are. You are in the first quadrant. Okay, you get your r. So r is equal to the x squared plus y squared. So it's going to be 3 squared plus radical 3 squared. Okay, so that gives you 9 plus 9 plus 3, which is a radical 12. Not the perfect square, but it's the 4 times 3. We can write it down as a 2 radical 3. Okay, so this is going to be your r. 2 radical 3. You want to find the data, so you go with the tangent of the data. Is y over x. And that is a radical 3 over 2. That's why I change it. Because radical 3 over 2, you cannot find, you can find, but it's not going to be an exact one. Okay, in the first quadrant, that's easy. So this is the tangent of the 30 degrees. Okay, so your format is going to be, so that's a 3 plus radical 3i is going to be equal to the r, which is 2 radical 3, cis, or just write it down, cosine of the pi 6 plus I sine of the pi 6. And then you're done. Okay, that's it. And that is going to be type, okay, type 1. Okay, any question? That's it. That's going to be the first case, the first possibility. Checking the second one. Okay, part B, z equal to 3 minus radical 3i. Okay, so this is it, the solution. Your x is equal to 3, in this case, y equal to the negative radical 3. And you are going to be in the second quadrant. So you are here. Oh, I'm sorry. X is positive, y negative, you are here. Okay, we are here on the fourth one. So we are going to find the r, which is going to be a similar one or the same one. So that would be 3 squared plus a negative radical 3 squared. So that gives us the same thing. It's a 9 plus 3 radical 12, which is going to be 2 radical 3. Okay, it's going to be the same, but the data is going to be different. So we go with the tangent of the data, which is y over x. Okay, the y is a negative radical 3, and this is going to be 3. So we get negative radical 3 over 3. Now you have to pick the correct one. Again, the same thing that we did before. For the positive one is a 30 degrees. You must be here. So it's 11 by 6. So the theta is going to be 11 pi 6. It must be 330 degrees to get, to get this number. Okay, so there you are. 3 minus radical 3i is going to be r 2 radical 3 cis cosine of 11 by 6 plus I sine of 11 by 6, and you're done. Just make sure pick the correct data. Okay, just get, just guess where you are. Okay, where is going to be your your position, and then that give you the result right away. Okay, so that is the case, the second case. Let's check the case 3, -1 plus I. So this is going to be, we're going to do quite a lot with this later on. Whatever we want to do for the rest of the course with the complex numbers, you need this polar form. So z equal to the -1 plus I. Okay, again, your x is a -1. Your y is +1. You check to see where you are. X negative, y positive, you are here. Okay, you are going to be in the second quadrant. So we go with the r. R is equal to the x squared plus y squared. Okay, so that gives you a -1 squared plus 1 squared. It's going to be 1 plus 1. So that gives a radical 2. So R is going to be radical 2. Okay, get the data. Y over x, which would be a -1. Some people, they miss this case for the theta. Tangent of theta is y over x. The y is 1. And that's a -1 that gives a -1. Okay, so again, the -1, you see, you are in the second quadrant. For the positive one, it's a tangent of the 45 degrees by 4. So you want to be here, so it's going to be 180 minus pi 4, which is 135 degrees. Okay, so don't miss it. A positive one is 45 degrees. You want to be the second quadrant is 180 minus 45. So in this case, the proper data is 3 by 4. Remember, you cannot pick any -1 because the data is a positive one. Okay, it's a unique angle between 0 and 2 pi. Okay, and when it's a -1, you may be here or you may be here. So that's why you have to locate it, make sure that you pick the correct one. Okay, now the answer is easy to write. So this is it. We have a -1 plus I, which is going to be radical 2 times cosine of the 3 by 4 plus I sine of the 3 by 4. So this means if you go to the table and you just substitute for this, you must get this one. If you substitute cosine of the 3 by 4 is negative radical 2 over 2. And this is radical 2 over 2, then if you multiply it, you will get the -1 plus I. Okay, that's a case 3. Any question? The next case is interesting. Okay, the last one is, yes, it's a -1 minus I. That is again the one that some people, they miss it. See? So z equal to, that's z equal to So what's going to be the solution for this one? Solution. So we get the x equal to the -1, and we have the y equal to the -1 too. Okay, so we identify the position we are. Negative, negative, you are here. On the third one. Okay, get the r. Again, r is going to be a square root of x squared plus y squared. It's a -1 and -1 that give you radical 2 again. Okay, it's a radical 1 plus 1, which is a radical 2. Again, you are not going to use your calculator. We don't use decimal numbers for the polar form. Okay, it must be an exact number. Okay, that's going to be your r. We are going to identify the data, so we go with the tangent of data. So what's going to be the tan of data is y over x. The y is -1, -1, which make it to the 1. Again, you see, 1 is the tangent of the pi 4, but don't miss it. Check to see where you are. You are in the second quadrant. You are in the third quadrant. You cannot pick the pi 4 over here. So you have to bring the pi 4 into the third quadrant. So you have to add 180. So this is going to be where you pick the data. So your data is going to be pi plus, I write it down for you so that you know that it's a pi plus pi 4, which is the 5 pi 4. Okay, so it's not pi 4, it's 5 pi 4 because you must be in the third quadrant. Okay, so now we can write the polar form. -1 minus I is going to be, we have the radical 2 times cosine of the 5 by 4 plus I sine of the 5 pi 4. So that give you, the conclusion that we're going to have. Okay, so be careful to identify this one correctly. As I told you, whatever we are going to do are going to be related to these numbers. Okay, there is an application. I just this practice one that I posted for you. I'm going to drop. I changed one of these problems for you. Okay, the format. I leave it as is, but there is something that we can use and find the power of the complex numbers. We don't want to rush that one. We talk about it later. So you better check this practice one later for the last two questions. I'm not going to test the complex numbers, but I ask you for something else just to give us the polar form for the time being. Then we get back to it again. Basically, what we are going to do, you see, look at this complex number that we have. The first application of these are going to be, you see, in calculus, you are going to be interested in the powers of these numbers. You see, -1 minus I. When you want to solve an equation, you may have to check what is -1 minus I to the 100. Of course, you can't do it. What we do, quickly we form this polar form. Then there is a theorem that tells you that if you raise this CIS to the 100, it's the same if you bring the 100 down. You see cosine of the 100 times 5 by 4. We call it the Moir, formulas. I'm not going to talk about it now. That's section 8.3. Okay, so I change it to some easy operation with the complex numbers for the time being. But the key is changing to the polar form. Okay, so that's going to be the one. Any question? Now let's go back and I do a couple of more equations for you from that practice one that we have time, some that's going to be different. So your quiz is going to be solving the equations or sort of the equation that we talk about it tonight. Okay, and the complex numbers, ordinary operation like the first example that we did from 8.1, and of course the polar form. So this is how we're going to give you the a short quiz. So let's get a couple of more of those equations that we didn't cover. Okay, so we did whatever we need for the this one from the practice quiz. Now I give you all sorts of the equation that you need in this number one, quadratic, there are two of those are different. I'm going to explain it. Okay, so this is again a practice. Okay, this is going to be practice quiz number 3, and we're going to give you focusing on number 1. We want to solve each equation. Solve each equation. Okay, you want to do it as usual on the interval. Okay, on the interval of, that's the way your book would be expressed is. And it's going to be x or theta, it doesn't matter. 2 pi. And they drop the equality, it doesn't matter. Okay, so what I'm going to do is, just to make sure to get every name, lots of quadratic that we did all of them almost. But this is part I and the J that's new for you. Part I is a sine of 2x plus a sine x equal to the 0. And the part J. Part J is cosine of the 2x minus sine x equal to the 0. You see, these two are different. We didn't practice on this, so we just give you some idea of how we're going to solve it. Let's see what is special about it. Okay, so let's take the first one first. Okay, we take the I for the solution. We go with the I part. You see, the something different about this one is that, look at this one. This is sine x, but this is sine of the 2x. So the angles are not the same. Okay, whatever we did before, all the angles were the same. This is a double angle formula. This is true for this one. So what you are going to do is you have to take care of it. You have to bring the formula for the double angle. Remember the sine of 2x, double angle? The sine of 2x was 2 sine x cosine x. You substitute. Okay, so we're going to do the first one. You want to solve this equation again. So what we do is we remind ourselves, oh, note that what? The sine of the double angle is 2 sine of the x times cosine of the x. Substitute. Bring it here. So what you have now? It's a 2 sine x cosine x plus sine x equal to 0. Now we can solve this equation. Solving these equations, different methods that we have in algebra too. Remember, in algebra, we have factoring method. We can use the factoring here. You see, look at this one. You have the sine x and the sine x as a common factor. So factor out the sine x and continue. So you factor out the sine x. The leftover is going to be 2 cosine x plus 1 equal to the 0. Now you know that each factor must be 0. Sine x equal to the 0. or 2 cosine x plus 1 equal to the 0. Okay, we take care of each one of them. And the first one, you want the sign to be 0. You check with your table, okay? Your table will give you x equal to the pi, okay? And the sign of the 0. The sign of the 0 is 0, and the sign of the pi is 0. Okay, the sign of the 0 is 0, and the sign of the pi is also 0. You can see it on your, okay, the unit circle, and the sign is the second quadrant. You see 0 and the 0. So x equal to the 0 or x equal to the pi is the solution. Okay, so this is going to be the first one. Now, how about the second one? The second one, you have to solve for the cosine. So that gives you 2 cosine x equal to the -1. So the cosine x would be -1/2. Now you have to find the -1/2. Okay, where are you going to look for? The cosine is negative. So negative is going to be, so you are going to be either here or here. Okay, this is going to be your angle. So you can check it with the table that we have. Or if you like it, the positive one is, this is the cosine of the 60 degrees. So this would be 122 pi third. Or here is going to be 60 plus 180, which is going to be 240. And the 240 would be 4 pi third. Again, you have it on the table. Okay, so basically the solutions are going to be, the solutions are, you have the x equal to the 0 from the first part. Okay, 0, pi, 2 pi third, and 4 pi third. You see, this would be the solution of your equation. It's a very popular example. And as you can see, the different, the technique is different. So as soon as you see this 2x, you realize that, you see, you realize that the 2x, your angles are different. One of them is 2x, the other one is x. So we change it. Quickly we change it to sine x cosine x, and then that gives you the chance to factor out the sign. You factor out the sign, you let each factor equal to the 0, and from the table you get 4 solutions. Okay, any question? Now the second one is more interesting. Look at this one. You have a cosine of the 2x and the sine of the x. So you have to change again. This time you have a cosine of 2x. You know the cosine of 2x, you have various options. Okay, let's go to the next page and take care of this one too. So what's going to be the J form? So we have a cosine of the 2x. Okay, cosine of the 2x minus sine x equal to the 0. Now, remember for cosine of 2x, we have 3 options. The formula that we have. You have cosine squared minus sine squared. And you have to find something which is going to be compatible with the sine. So that formula is not a good one. But cosine of the 2x is also 1 minus 2 sine squared, which is compatible to this. Okay, you have 3 formula for the cosine of the 2x. So just pick the nice one. The nice one is, you note that, this is it. You note that the cosine of the 2x. Okay, cosine of the 2x is what? Is 1 minus 2 sine square of x. So that would be the best choice. Because if you substitute, so now you are going to have a 1 minus 2 sine square of the x and 1 minus sine x equal to the 0. Any question? You know that this is now a quadratic. So rewrite it and just use the C substitution to take care of it. So that gives you negative 2 sine x minus sine x and the plus 1 equal to the 0. Sorry, that's a square. Okay, so we change it to the quadratic. So we have to take care of the quadratic one. We have to use the Z substitution. We call the Z to be sine square of the x. So we end up with a 2z squared minus a z plus 1 equal to the 0. We have to take care of it, factoring or just quadratic formula. So I'm going to try the quadratic formula to see.
Professor, Z is sine x, I think.
Oh, I'm sorry. Yes, you are right. Sine x, thank you. Yes, sine, that gives sine squared, okay. So I try the quadratic one. Negative b would be negative 2. Okay, plus or minus. Oh, I'm sorry, b is negative 1. Okay, remember ABC. So the b is negative 1. So b squared, negative 1 squared minus 4ac. A is a negative 2. And this is a 1. Okay, there you are. Divided by 2a, 2 times a negative 2. So this is going to be equal to, we get a 1. Is a plus or minus the square root of negative 1 squared is 1. You have double negative here, make it a positive, so that gives you 8, which is good. Divide by negative 4. So 1 plus 8 would be 9. So z is equal to, we have 1 plus or minus square root of 9. Okay, divide by negative 4. So that gives you plus or minus 3, negative 4. You have 2 possibilities. Okay, if you go with the positive 1, 1 plus 3 over negative 4. So that gives you 4 over negative 4, which is a negative 1. Okay, if we go for the other numbers, so that gives you 1 minus 3 over negative 4. So that's a negative 2 over negative 4, which is a half. So both of them are nice numbers. And they give you 2 new equations to solve. Okay. So this is going to be the case. So we are going to continue with the z. Z equal to the negative 1. So z is the sine. So sine of x equal to the negative 1. Okay, you check with your table to find out. You know that the sine of the 3 pi half is negative 1. So that gives you only one solution. X equal to the 3 pi half, 270. Okay, there is no second one. So we check the other one. Z equal to the half. So it's going to be sine x equal to the half. That's easy. Sine is positive in the first and the second quadrant. And the 1/2 is the sine of the 30 degrees. So that gives you 30 degrees, which is, okay, it's going to be pi 6. And the other one is in the second quadrant, which is going to be 5 by 6. It's 30 degrees and 150 degrees. There you are. So the solutions, okay, the solutions are going to be, that's it. We get the x equal to the pi 6, 5 by 6, and of course 3 by half. The final answer. Okay, so these two are a kind of unique problem. Okay, problems that we have. Now you know it. It's a double angle. You do the job, okay, but you have to, change them into the same angle. So that the first part is important, especially in the case of the cosine. We have 3 options. Okay, so because there is a sign here. There's a sign here, so the option is going to be 1 minus 2 sine square only to get these numbers, okay? So most of them are the one that we did, but this two was a unique one, okay, to get these numbers done. There is a situation that you have to take the square root. You have in 1C, I do 2A for you. These are all the same. Okay, so I listed so that you know that what is going to be, okay, and that. So the other one is 2A. 2A, you want to solve this equation for sine square of x minus 3 equal to the 0. It's very similar to the 1C. I write it down so that you know that you have to know these. 1C is for cosine square minus 1 equal to the 0. They are again a group of problems that from time to time you may see it. Let's see what is special about these. You see, in both of them, you solve for the sine square, you see. Sine square would be 3/4. You take the square root and then you can solve it. Over here, you solve for the cosine squared. Cosine square would be 1/4. You take the square root, positive negative 1/2, and then you'll be able to do it, okay? So again, this group are popular. Even it can come with a tangent, but the sine and the cosine are more popular, okay? So that's another group that we have to know it. So we take this one. So what we are going to do is, this is going to be the solution of the 2A. So we have to isolate the sine square first. So that's it. It's going to be 4 sine square of x equal to 3. Divide by 4 and then take the square root. So it's going to be sine square of x equal to the 3/4. Take the square root, make sure you use the positive negative. Positive negative, this is going to be 3/4. You take the square root on the top and the bottom. Radical 3, radical 4. Radical 4 is 2, so you get positive negative. Radical 3/2. You see, so you have two cases. Sine x equal to the radical 3/2, and the sine x equal to the negative radical 3/2. Okay, so just solve for the sine square or cosine square, and then take care of it. That's easy. Radical 3/2. The sine is positive in the first and the second quadrant, and this is okay, the sine of the 60 degrees. So this is it. In this case, we get x equal to the pi third, one of them, 60 to the second quadrant, 120, 2 pi third. Again, you check this quickly from your table, and the sign is the second quadrant, and this is it. You see radical 3/2, which is the pi third, and 2 pi third quickly we get it. Okay, that's going to be the one. Now we go with the second one. So in this case, you see, in this case, the sign was, in the first or in the second. But over here, you want the sign to be negative, so we are going to be in these two places. Quickly, you know where you look for when you check your table. So what is going to be the case? For the positive one, we get 60 degrees. So for the 60 degrees, to get to this part is going to be 60 plus 180, which is going to be 240. So the x would be, okay, this is going to be 4 pi third. So that gives you 240, and over here is 360 degrees minus 60, which is 300. So the 300 is going to be 5 pi third. Okay, so it's going to be your 4 solutions. So identify the location that you are, you see, then quickly you can check with your, with your table to find them. It's very quick. So that's it to get the solution of the equation. Okay, any question? Quickly, I give you the solution for 1C2, which is very similar. Okay, so that's a 4 cosine square of x equal to the -1 equal to the 0. So for the cosine squared, so it's the 4 cosine square of x equal to 1. So cosine square of x a quarter. Take the square root. That's easy, plus or minus 1/2. So we have 2 solutions to check. Cosine x equal to the half, and the cosine x equal to the -half. Okay, cosine is positive in the first quadrant and the fourth. You see that is going to be the cosine. So you are here. 1/2 is the cosine of again, is 60 degrees. So x is equal to the pi third. And this is going to be the fourth quadrant with 300 degrees, which is 5 pi third. Okay, 1/2 is a cosine of 60 degrees, and the other one 300. Cosine negative, where you are. Cosine negative, the second and the third. 1/2 is a cosine of 60 degrees. If you want to come to the second degree, it's going to be 120. 2 pi third. And if you want to be here, is the 60 plus 180, which is 240. 4 pi third. So you have 4 solutions. All of them are using calculus. We use it quite a lot. Because in those courses, they are not going to give you anything complicated, you see, because they want everything to be nice to be able to apply it. So they put, this would be something like y equal to 4 cosine square minus 1. Then they ask you to do something to that y. Then you end up with this. So the similar one, the other one is going to be used. Nothing complicated. That's it. Any question? So I just revised that practice quiz. I just got the last question. For the rest, we did all of them almost. And then if I get time, I may post a take-home one for you, so that would help you. And because we need one for this part, give you a couple of equations in advance so that you can solve them. Okay, and then repeat it on the quiz. Okay, so that's going to be quiz day. We collect the assignment on the day of the quiz. It's just 4 sections as usual. You can submit it on the canvas. That would be easier. If you can't do it, you can email it. Okay, as usual. I open up somewhere on the canvas for you, so you can do that one too. But the take-home one, when I post it, you have to go through the canvas. Okay, to give you 2 points and would be useful. You need something to practice more for this one. Okay, any question? So as I told you, this chapter 6 really, if you want to do something, take higher courses in mathematics, this is the most important part that you need. With that, complex numbers that we are going to continue depends if you want to be, engineering measures, you use it later on. Okay, it's going to be very useful. Okay, that's fine. Okay, so I will finish your test. I will post it. Wait when I done it. Then if you have any question, if your test is missing anything, then you let me know. Then I check it for you. Okay.
Yes, teacher.
Yes, yours is, I got it by email, so I will check that one when I'm done with all the other gradings. But wait when I'm done, then otherwise Gmail me. Okay, that's it. Have a good night and take care. Bye-bye.
Thank you, teacher. We
Okay,
appreciate
thank
it.
you. Thank you.
Have a good
Bye-bye.
one. Thank
Bye-bye.
you.
Bye-bye.
Thank you.